Hey everyone, welcome back to the channel. Today we are breaking down one of the most powerful sorting algorithms in computer science, the quicksort. It's super fast, elegant, and used everywhere, from databases to real-world applications. So what exactly is quicksort? Quicksort is a divide and conquer algorithm, meaning it breaks a big problem into smaller ones, solves them, and then combines the result. That's the basic idea of quicksort. So let's visualize the quicksort function. Here we have an unsorted array. First thing we have to do is select a pivot. So to select the pivot, we can select the pivot at the beginning of our array, or in the middle, or at the end of our array. So in this case, we'll choose the rightmost element of the array as the pivot. So in order to sort this array in the quicksort function, we need two indices. One is I and one is j. We have to compare j's value with the pivot value. If the value of j is greater than the value of the pivot, we increment j by 1. And then again we compare 2 with the pivot value 5. This time the value of j is less than 5. So we increment I by 1. And then we swap the values of I and j. And again increment I by 1. And then compare with the pivot value. So 4 is less than 5. We increment I by 1 and then swap the values of 4 and 8. And then again we increment j by 1. Compare 7 with the pivot value 5. So this time j is greater than 5. So we increment only j. And then we compare 1 with the value of 5. So 1 is less than 5. We increment I by 1. And then we swap the values of I and j. And then again we increment j by 1. Now we compare 3 with 5. 3 is also less than 5. So we increment I by 1. And then we swap the values of I and j. Then again we increment j by 1. And then compare 9 with the pivot value 5. 9 is greater than 5. So we increment j by 1. And then we compare 6 with 5. 6 is also greater than 5. So we increment j by 1. And j goes to the position of the pivot value. So now we have to increment I by 1 and then swap the values of j, the pivot value, and the I value. So the pivot value comes to the middle and the value of I comes to the end. Now our pivot value is in the right position of the array. So all the values left to the pivot element are less than 5 and all the elements at the right of the pivot element are greater than 5. So the pivot element 5 is now in the correct position of the array. Okay, now we have two unsorted arrays left to the pivot element and the other one is right to the pivot element. So now we have to sort these two arrays separately in a quicksort function. So first we will sort the left array in a quicksort function. So we have two indices called j and I. First we compare the j value with the pivot element. So the value of j is now 2 and the pivot value is 3. So j is less than 3. We increment I by 1 and then swap with the j value. Here both the values are the same. So we increment j by 1. So then we compare 4 with the pivot element 3. 4 is greater than 3, so we just only increment j by 1. And then we compare 1 with the pivot element 3. So this time 1 is less than 3, so we increment I by 1 and then swap the values of I and j. Okay, then we again increment j value by 1. So the pivot element now becomes the j value. And then we increment I by 1 and then we swap the values of I and j. Now the pivot element is in the correct position of the array. The elements left to the pivot element are all less than the pivot element. An element right to the pivot element is greater than the pivot element. So 3 is in the correct position of this array. And then we again sort these two arrays separately. So again we have two indices I and j. We compare j's value with the pivot element 1. So 2 is greater than 1, so we increment j by 1. And then the pivot element becomes the j value. So we increment I by 1 and then swap the values of I and j. So now 1 is in the correct position. So we can connect these arrays together because they are already sorted. So now we can connect this array to the pivot element 5. The same process is done to this array too. So after we sort both the arrays, we can connect these two arrays back to the original array. So we connect this array with the pivot element 5 and they sorted this array to the right of the pivot element. Now we have sorted the array in an ascending order. So I hope you all got a clear idea about quicksort. So quicksort function is a recursive function. As you all can see, we split the array into two separate arrays. So this is a feature of recursive functions. I hope you have a clear idea about quicksort function by now. Then we'll move on to the code explanation of quicksort. This is the sample Python code for the quicksort function. So to the quicksort function, we have a parameter to pass our initial array. So for the base case, if the list has 0 or 1 element, it's already sorted. So we just have to return the array. So for the other cases, we had to select the pivot element. For this instance, we select the last element of the array as the pivot. Array minus 1 means the last element of the array. Then we partition the array as two lists. One is left list, the other one is the right list. So for the left list, we select all the elements less than or equal to the last element, which is the pivot element of our array. And for the right list, we select all the elements of the array which are greater than the pivot, except for the last element of the array. And then we return the left list plus the pivot value plus the right list in the quicksort function and then return it. And then again we have the left list in a quicksort function and the right list in a quicksort function. So the recursive features continues. And then again we pass the left list to the parameter here and then again repeat this task. We have a sample array called data here. So we can pass this data array into the quicksort function and see the initial array, the original one, and the sorted array. So let's run the program. Now you can see the original array and the sorted array, which is sorted in an ascending order. So that's all about the quicksort function. I hope you all got a clear, concise idea about the quicksort function. Thank you everyone.